Greetings, everyone. Today we're going to explore rationalizing radicals. Now, this coincides with our video about dividing radicals. In my dividing radicals video that is on this playlist, we had all nice, clean denominators, right? And now we're going to explore what happens if it's not nice and clean. So let me connect this to something you already know. Can I divide 5 by 0? No, that's undefined, right? We can't divide by 0. It doesn't work. We also can't divide by a square root. We also can't divide by pi. There's so many things. If we're going to divide, it needs to be by something clean, as I like to say, an integer, okay? So because of this mathematical rule, we can't have radicals in a denominator. Today we're going to explore how to get rid of that. How do we deal if there's a radical left in the denominator? In our foldable, you're going to be on the last tab, but these are super easy to jot down in your notebook. Let's jump to the top half of that tab, and let's just take down some notes. So again, I'm stressing this. You cannot leave a radical in the denominator. So you could do all the simplifying, break everything down. If you have a radical left over in the bottom in the denominator, we need to do something about it. So here's what we're going to do. Here's what's new. You've probably never done this before. To get rid of the radical in the denominator, multiply the numerator and denominator by the radical in the denominator. Make this part bold. If you're a highlighter type person, please do so. Maybe underline it, write it bigger, put a star by it. This is the step that's new and that you're going to have to memorize. Multiply the numerator and the denominator. Maybe you want to jot down multiply the top and bottom by the radical in the denominator. Once we've done that, then we can simplify a little bit, right? We're going to get some cleaner numbers. Things are going to work out. So we want to simplify, as always, at the end as much as we can. All right, let's apply this topic. So example 1, we're going to start off basic. There's nothing to simplify. Okay, square root of 2 doesn't break down. There's nothing I can divide. So let's just do the rule. The rule says multiply the numerator and the denominator by the radical in the denominator. See how I did that? I took that denominator and multiplied it on the top and bottom. Let's simplify. 8 times radical 2 is just 8 radical 2. We can't multiply an integer times a radicand. It just stays. The top can be messy, right? Let's look at the bottom. Square root of 2 times square root of 2, well, it's still under the square root, and if I multiply those radicands, I have 4. Oh, well, what's the square root of 4? 2. See how that worked out? Let me highlight this for a second. When you multiply a square root of 2 times a square root of 2, it'll always simplify down to a 2. Square root of 50 times square root of 50 is just 50. Square root of 1 million times square root of 1 million is 1 million. It's always going to be the radicand. Now I have one more step though. I do have to simplify because these are integers that divide. We have a 4 with a square root of 2 remaining. Let's try this again with these 3's. Multiply the top and the bottom by the square root of 3. The top stays messy. They're unlike. The bottom, let's see if we can do this shortcut. Follow me. Square root of 3 times square root of 3 is just 3. A radical times itself is just the radicand because it would be square root of 9, which is 3. Okay, if you need to write it out, please do so. Next, I see that I have 3 divided by 3 is 1. So I have square root of 3 remaining. Let's take a look at the next one. Multiply top and bottom by square root of 5. So the top stays messy. Use the shortcut square root of 5 times square root of 5. If you wanted to write it out, it's square root of 25, but square root of 25 is just 5. Radical 5 times radical 5 is 5. Let's divide. 15 divided by 5 is 3, and the square root of 5 is still hanging out. Let's look at example 4. There's nothing I can simplify, so let's just jump straight into multiplying top and bottom. Now notice the 3 doesn't matter. The 3 is an integer out front. We don't need it. We just multiply by the radical. So on the top, I have 1 square root of 15. And you know what? I don't need that one. On the bottom, I have the 3 hanging out. Square root of 15 times square root of 15 is just 15. Right? Here is when it's really beneficial to understand that property. Because otherwise you have a huge number. You're going to have to use your calculator. Just know that a square root of 15 times square root of 15 is just 15. It'll make it easier. Now this 3 and 15 are next to each other. That implies multiplication. So we multiply them, and the top stays square root of 15. All right, let's look at the next one. You know what? On this next one, let's do a little bit of work first. We can reduce these numbers, right? Let's go back to we did dividing first for a reason. Okay, if I reduce this down, I can divide both 12 and 15 by 3. So that gets it down to a 5 and a 4. That's better. See how that worked out? I reduced the radicands as a fraction. Okay. What this allows me to do is now I'm going to multiply top and bottom by square root of 5. I'm trying to get the radical out of the bottom. Ooh, look at that numerator. I can actually multiply these. They're both radicands, so I have square root of 20. In the bottom, that 2 is still hanging out. Square root of 5 times square root of 5. Use that shortcut. It's just 5. That would be multiplication. Square root of 20 breaks down. It breaks down to a 4 and a 5. Well, square root of 4 is 2. Square root of 5 is bad. 10 is still hanging out. One more step. Look at those 2/10. 2/10 is 1/5. Are there other options? Yes. Let me show you something. Did you guys notice what I didn't do that I could have done? Let me show you. Right? And here's where I'm saying there are multiple pathways when dividing. You guys, square root of 4. Look at that. The square root of 4, I could have done this first. Square root of 4 is 2. 2 divided by 2 is 1. Right? Would that have been easier? Possibly. Let's multiply top and bottom by square root of 5. Square root of 5 over 5. You can get the same answer, right? Different pathway. It's what you see first. It's what you simplify first. It's what you acknowledge first. You could have not even reduced. You could have dealt with that 15. Sure, why not? It would be big numbers, right? Like, I don't know if I want to deal with 12 times 15. Could I have done it? Yes. So on the bottom, I still would have had the 2 times the 15. But then on the top, I would have had to have taken 12 times 15, which is 180, right? Like, I'd have to reduce that. Could I? Yep. Okay, so we can get there multiple ways. Don't let your friends, your neighbors confuse you. Okay, make sure you understand that. That would be a good problem to try again on your own. All right, let's look at this next one. I'm going to reduce this fraction first. So I'm going to rewrite the problem. 8 and 12 can both cut down by 4, which gets me to 2 and 3. It just makes the number smaller. So I'm going to multiply top and bottom by square root of 3. All right, let's look at that top. All I can multiply is the radicands. So I have 4 square root of 6. On the bottom, square root of 3 times square root of 3 is 3. 3 times 3 is 9. And 4/9 doesn't reduce. Square root of 6 doesn't reduce. That's all I got. All right, let's take a look at these last 3 examples. One thing you also want to recognize is if something's a perfect square or can be broken down right away, consider doing that first, right? 20 breaks down to 4 and 5. Square root of 4 is 2. Square root of 5 stays. Square root of 36 is 6. The 3 and the 6 are next to each other, so we multiply them. 2/18 simplifies down to 1/9. So even though there's a radical on the bottom, it doesn't mean you're going to have to rationalize. Sometimes just using the rules you already know takes care of everything. 16/12. Let's simplify that for sure. We can divide them both by 4, so we get 4 and 3. Oh, let's separate our radical. Square root of 4 is 2. Wow, those numbers are way easier now, right? So let's multiply. I still have to get rid of the radical in the bottom. My numerator is now 2 square root of 3. Square root of 3 times square root of 3 is 3. This is an example of something you're going to do a lot next year in geometry. So be prepared for all these 2's and 3's and radicals. Lastly, example 9, you have some options, but definitely I encourage you to reduce first. So square root of 27 breaks down to 9 and 3. Square root of 9 is 3. Okay, that makes things easier. 72 divides by 36. Square root of 36 times 2. That breaks it down a lot. Square root of 36 is 6, and I have square root of 2 remaining. Let's multiply top and bottom by square root of 3. Now I'm going to do two things at once. 6/3 reduces, you guys. That's just 2 over 1. Now let's deal with the radicals. Square root of 2 times square root of 3 is square root of 6. They're both radicands. We multiply them. Square root of 3 times square root of 3 is just 3. And 1 times 3, well, that's just 3. So I'm just going to get rid of that. And there is my final simplified radical. Again, I encourage you, please seek out other videos. You can learn so much from other people, other teachers. So consider on YouTube looking up Rationalizing Denominators. Same title. You'll find so many other options if you need. As always, check out Google Classroom to see what the task is. Let me know what you need. And until next time, have a good one.